funny name, perfect square trinomials. Because if something's a square, have you ever seen an unperfect square? Like, is an unperfect square like a rectangle? Then you call it a rectangle. If it's a square, it's a square. But they call these perfect squares. Because not only does it make a square, it really makes a square. That's perfect. Okay. So the idea is anytime you square something, you could represent that with the chart method as a square or a perfect square. And so if I have a plus b, wow, that's yellow. If I have a plus b squared, that means a plus b times a plus b. And I could draw it as a square. And a and b in this square are shown to be like, oh, they're probably not the same numbers, so I have them slightly different lengths. But if I fill that square out with the chart method, the same thing as if I FOIL this. My first ones would be a squared, my outsides would be ab, my insides would be ba, which is the same as ab, and my last ones would be b squared. Giving me a squared plus 2ab's plus b squared. Perfect. That makes it a perfect square. So if we have a perfect square and it's two binomials, we get what's called, oh, I've got that already. We've got something called, the answer is called a perfect square trinomial. You can highlight that in your note. And what always happens, right up to the bottom here too. This is where I highlight it. Highlight it right there. What always happens is that this is a perfect square and this is a perfect square. In other words, those are both square numbers. And what we're going to do today is we're going to look for that as a possible shortcut in level 5 factoring questions. So to recognize this, if the first and last terms are perfect squares, it might be a shortcut to factor it. It might not work, but it might be a shortcut. And based on how the textbook arranges questions, it usually is. So this is the level 5 question. Level 5 questions we usually do with the grouping method. But if you say to yourself and you look and you say, hey, this is a perfect square because it's 3x times 3x. The 9 is 3 times 3, and the x is x times x. The green one here, that's a perfect square because it's 7 times 7. So instead of doing the grouping method, which is on your quiz tomorrow, the grouping method is, so maybe we want to review it anyways after we do this question. But you can go right away and say, well, I'm going to try 3x and 3x and 7 and 7. I'm going to try that as a shortcut. What's my outside? 21x. What's my inside? 21x. Does that ever add or subtract to give 42x? Yes, it does. And they would both need to be plus to get a plus 42x. And so it's a nice shortcut if it works. It's a great thing to try because if it works, you save yourself a lot of time. If it doesn't work, you would probably have to go to your product and sum of your grouping method. So if I multiply 9 times 49, how good's your mental math? Is that what? 441? No? 401? Go 441? What's 9 times 49? I'm going to go with 441. Which works out, 441. Perfect. And my sum? That one's super easy. Remember, your sum is always this number? 42. The grouping method doesn't make this question any easier. In fact, it makes it quite a bit more difficult. Sometimes just factoring normally is the easiest method. 441, you would have to go through your calculator to find all the things that multiply to 441 to figure out that the two numbers are 21 and 21. Then the grouping method would say, once you found out that 21 times 21 is 441, and 21 plus 21 is 42, as your two numbers, you break up the middle number to be 21x plus 21x. So those two numbers, that 42, I now rewrite as 21 and 21. And then I look at my first two. What's in common? A 3 and x, leaving me with 3x plus 7. Second one is what's in common is a 7, leaving me with 3x plus 7. The 3x plus 7 is in common. I can factor that out, leaving me with a 3x and a plus 7. That's the grouping method. That's on, I have one tough one on your quiz tomorrow. Wait. I won't make your product go over 400 though. Up to 400, yes. Yeah. Yeah, I'll say decomposition. I might say grouping and decomposition just so that you know. Okay? And you can factor it the regular way and get some marks for the answers if you just know how to do it directly. But forget the method, you can get some marks, but then you would lose some marks for not showing your way. So it's a really nice shortcut to try. If this, again, that's 3x times 3x, and this, hey, that's 5 times 5. If those are perfect squares, then we think, well, maybe this is a perfect square trinomial. So I'm going to try 3x and 3x and 5 and 5 as my first choice and see if it works. What's my outside? 15. What's my inside? 15. Does 15 and 15 ever make 30? Yes. Now we need a negative 30. So does it make sense that you would need a negative 15 and another negative 15 to make a negative 30? Said the day after is better?
Yeah. Literally any day but Halloween.
Wouldn't Halloween be better than the day after?
No.
No. The day after Halloween is that special day. Have you ever celebrated that special day? The bring your math teacher treats you don't like day? It's a wonderful day right after Halloween. Especially chocolates? Double check it, it factored perfectly. So it's a nice thing to check to see if it works. But you could get, like, I could make one. Should I make one for you? 4x squared. Ooh, that's a perfect square. And I could put a 9 here. Ooh, that's a perfect square. And I put 20 here. And we could ask to factor this one. And so you try the shortcut. 2x, 2x, 3, and 3. Check your outside is 6. Your inside is 6. Does 6 and 6 ever add or subtract to get you 20? No. So, just because the first one is a perfect square and the last one is a perfect square does not guarantee that it's going to work. So what do we do in this situation? Well, you could keep trying with factoring. Keep trying different outsides and insides. So for example, you're like, okay, 3 and 3 didn't work. I'm going to stay with 2x and 2x. What's another possibility for 9? 4 times 5 is not 9. Oh, we have to check for multiplying, not adding, right? So what are our last ones? Other option for 9. 9 times 1. So we'll try it. 9 times 1. What's my outside now? 2. What's my inside? 18. Does 18 and 2 ever make 20? Yes. Oh. So even though the first one didn't work, trying the next possibility, we got lucky this time, that one worked. If the 9 and the 1 didn't work, then you would have to go to 4x and 1x for the first ones as the next possibility. Now, with level 5 questions, because there's so many possibilities, that's why people like the grouping method. Because if you happen to guess right on the very last option, just trying different things and figuring out what works could take a long time. So in that reason, people like to say, okay, 4 times 9, that product is 36. My middle number is a 20. How long does it take you to figure out the numbers? Two numbers whose product is 36, sum is 20. It is something and something else. 18 and 2. So then, if we did the grouping method, you would rewrite 4x squared, and instead of the 20x, you would write 18x plus 2x, and you still have plus 9. Right? So what I've done is this orange part, which was the 20x, I took my two special numbers that worked and rewrote them. And this is a good one to review because in the 4 and the 18, I can pull out a 2. And in the x squared, I can pull out an x, leaving me with a 2x and a plus 9. But in the second 2, there's nothing in common. When there's nothing in common, you just pull out a 1. And you would get 2x plus 9's in common. Factor that out. That would leave you with a 2x and leave you with the plus 1. And you get the exact same answer that we found. So as you improve your mental math skills, I like it if you can just go there and get the answer right away. But that, every time you do that, you're going to be really pushing your mental math skills because you're going to be multiplying and adding and holding a bunch of numbers in your head. But as you do that more and more, you'll get faster and faster and be able to do it better and better. Okay? By the time you get to grade 12, a lot of people have forgotten the grouping decomposition method because they're comfortable just doing it direct. But it is a nice method, especially if things are more complicated. All right. Oh, I had the same brainwave that I just did with you with this one. It looks like a perfect square, but it doesn't work. Okay? So, before you do the grouping method, okay, I want you to try at least 4 different options where the first one works and the last one works. And then check the outside and the inside to see if you get it working. If you get the answer before 4 tries, perfect. If you get 4 wrong ones, okay, I'm going to give you an example of a wrong one. Here, the first one's given to you. Just write wrong beside it. Can you see that your outside is 6 and your inside is 6? Outside and inside don't make 37. That one's wrong. Try another one. You have to come up with 4 wrong ones or 1 right one. And then I want you to do the grouping method. You want me to do another wrong one for you? Okay, the wrong ones though, the first ones have to work. And the last ones have to work. So even the ones that don't work for you, the first ones have to work, the last ones have to work. So that's really easy to figure out ones that the first ones work and the last ones work. Then you just check the outside and the inside and either say right or wrong at the end. But this would be absolutely the first thing I would try. I would notice the perfect squares, and that would be the first one I'd try, and it doesn't work. Did anybody try this one and get it wrong? Did anyone try with minuses? Do you see that the first ones work? Give me 4x squared. Minus and minus gives me the last one. It's obviously going to be wrong because both my outside and inside are going to be negative, and I need a positive. So minuses would be a really bad one to try, but it's still considered one of the wrong ones. So when 2x and 2x doesn't work, do you see that 4x and x is another option? Okay? Did anybody try this one? 9 and 1. And it doesn't work. Because what's your outside? 4 and 9 makes 13. It's wrong. But as you get them wrong, you start to notice certain things. One thing I hope you started to notice is that this number is 37. It's pretty big. So when I put things like 4x and x, to get a big number, can you see that my 9 over here causes my outside to be 36? That makes things bigger. And then a 1 here. So now I have 36 and 1. I'm getting pretty excited. It worked out. And usually what I find for students is that I'm very happy if they try this one first and get it wrong. Okay? I like that you try that one first because that looks like a really good shortcut if this is a perfect square and that's a perfect square. Okay? Then most students, I like it if they try this one next and get it wrong because you're being systematic. You're like, I tried 2x's with 3's, it didn't work, so now I'm going to try the 2x with the 9 and the 1. And it didn't work. This This one would make me mad if you tried it. Well, I'm not mad. Do I really get mad? But I'd be like, by now I hope you're seeing some patterns, right? You need a plus 37. Using the negatives would give you a negative number. That seems like a little pointless to try. Okay? But I think what most students would do is they would go from here and probably get that one next right away. Because now that you've got some wrong, you're starting to see what you want, and you're smart. And so if you start to see what you want, you're going to do things to get what you want. That's a smart decision, and you guys are smart. So I think that most of you would probably maybe take 3 tries to get this, and that's not too bad. Compared to the grouping method, okay, grouping method here, your product is 36, your sum is 37. Can you see the 2 numbers that do that? 36 and 1. So then you would break up that middle number, 4x squared plus 36x plus 1x plus 9. What's in common in the first 2 is a 4x, leaving you with x plus 9. Nothing's in common with the next one, so we take out that plus 1, giving us x plus 9. And we get x plus 9. Take that out, leaving us with 4x plus 1. I don't know, the grouping method seemed pretty quick in this one too. But when we look at our last example, again, this is a perfect square, it's 4x and x. This is a perfect square, it's y and y. I would try that first. What's my outside? 4xy. What's my inside? 4xy. If you take 4xy and 4xy, could you get 8xy? Yes. So here, checking the perfect squares first worked out perfectly. All right, we will end there today.